Hi Flight Simmers community. Today I'm going to show you my button box that I built for Microsoft Flight Simulator 2020. I wanted to put the main A320 functions. So these functions in Flight Simulator are general functions. They will be applicable for the A320 as well as other aircrafts. The main difficulty when I built this button box was that I wanted on-off switches and push buttons with integrated LEDs. Then I can be able to see the status of the buttons directly on the box. In fact, I wanted to have something like in real cockpit. The first thing that I did was to design the button box inspired by the A320 FCU as well as the external light panel, and all of these buttons are plugged in a LeoBodnar board. So the main goal of this video is to understand the principle of button box, and so you can build your own box. The very interesting thing is that it's fully customizable. You can build exactly what you want. I will show you the example of my button box, how I build it. So I will start by the design, then I will show the build. I will show some typical stuff like on-off switch with integrated LEDs, as well as some push-button self-locking with integrated LEDs, on-off on switch, rotary encoders, and a momentary turning button, etc. So we'll explore all of these button wiring, and at the end there will be a software part. This is the design of the button box that I built, and with this I can fly the A320 without clicking a lot in the virtual cockpit once in the air. On the left of the panel I have the external lights panel with strobe, beacon, wing, nav, logo, etc. And I built it with on-off switch with integrated LED powered by 12 volts. There is the nose light switch, which is a 3 positions switch, on, off, on. This is a two-way switch. One way is used for illuminate LEDs in the takeoff or taxi position, and the second way is used to plug into the LeoBodnar board. This button will be waiting because this function is not implemented in the Flight Simulator this time. I hope there will be this function in the future, and if so, this button will be there. It should be noted that the nose light in the A320 of Flight Simulator 2020 it moved when you activate the landing light, but you can't control it directly with a switch or a button to bind. How this external light panel was going to be dark, I built a system to illuminate this panel with some LEDs and potentiometer to adjust the brightness. The LED is going to be white, and there is a 1 kilo ohm potentiometer. As well as the nose light, I plan to install a seatbelt and no smoking switch. If in the future the function will be available, the switch will be there. Anyway, this switch can be used also with X-Plane. On the top of these two switches, you can see two grayed out cycles. I keep the place for two rotate button for the zoom and the mode of navigation display if the function will be there in the future. I've planned an anti-ice button to react quickly if some ice appear on the plane. I was very surprised by this function in Flight Simulator because this function doesn't exist on X-Plane. When you fly a little plane and in a few seconds you have the window completely white with the ice and you don't found the anti-ice button and a few seconds later you are on the ground completely crashed. This very confusing, and then this button will be handy and this will be very useful. So then you have four rounded buttons for speed, heading, altitude and vertical speed. I used for that four rotary encoders. This is useful and it's in a real cockpit. These rotary encoders have push button integrated. Then if in the future there will be a function in the A320 to switch between manage mode and selected mode, I will be able to bind this push button to switch the two modes of the A320. At this time you must click in the virtual cockpit to switch between these two modes. These buttons are very useful also if you have head tracking, because you must pause the head tracking to click on the buttons because it moves a lot. Then you can rotate your altitude knob while you are admiring the landscape. So I've put an AP button for the automatic pilot. It works very well. I've already tested it. There is a lock button to capture the localizer of the ILS or VOR radio. There is an ILS button, but the function seems to be not be implemented at this time on the Flight Simulator. There is an approach button, which also works very well. You can notice that the lock and the approach button works in the A320 of Flight Simulator, but the button in the virtual cockpit will be not illuminated. This is a bug, but the function works because you can see on the PFD that the lock and the glide will be waiting and captured when the ILS is in function. There is a reverse button to activate on the landing for stopping the aircraft. Then you have three rotary momentary buttons. You can turn it on the right or on the left, and then when you release it, it comes back on the center position. These buttons are illuminated by 12 volts. I have three buttons for the flaps to increment the flaps, the spoilers and the trim. Special thing for the spoilers, you can take out the spoilers by turning the button in the plus position, retracting in the minus position. In X-plane, when you are in a retracted position and you turn in a minus position the button, the spoiler will be armed, but in MFS there is not this function. So I put a button to arm the spoilers. Ground spoilers are used to auto-brake the aircraft when you are landing. You arm the spoiler by pressing this button, and you set the auto-brake on medium or low if the track is long enough. and on the takeoff to auto brake before V1. Below I have a button for the parking brake. This is a push button I found on AliExpress with an integrated red light. This button is used in the car dashboard for those who have an electrical parking brake in their car. Then I have a two-way switch for the landing gear. I've wired it with the three bicolor LED, red and green. This button is a bit special because you must pull up it to change the position. So it simulates very well the landing gear operation in a real aircraft. You must pull up to down or up. And I built a rounded piece of wood to facilitate the handling of this switch. And to close this design presentation, we have a power button. This is a self-locking power button with integrated blue LED. This button box is powered by 12 volts and 1.5 ampere power supply, which I already have. I just have to buy the plug pieces. Behind this power supply I have a fuse box with a typical 12 volt fuse you can find in the cars. I thought that it was very sufficient because with all LEDs illuminated, the circuit will not use more than 0.55 ampere. The size of this box is 10 by 50 centimeters, which take less place on the desk than a square-shaped button box. I didn't make a detailed plan with measurements. I built it on paint and I put it on the screen on the 1:1 scale, and I measured on the screen the position of the buttons to drill the plate at the right positions. This is my old dirty plan of the wooden box, which I made it with 10 mm thickness wooden pieces. As you can see, the top is sloping by an angle of 14 degrees. That will mean that you can't put the buttons on the right side of the board because it will hit the back of the box. Some of the buttons are very long, like the rotary monetary button, which are 4 centimeters long. So I've taken these pieces, which is the more restricted, and calculate the distance of the drilling of the top plate to hit just the back of the box, and then I aligned all the buttons with these pieces. On the back of the box there is the LeoBodnar board, which I buy it directly on the website. This is 64 buttons, the BBI 64. At the beginning, I've planned to use a 3 mm spacer behind the LeoBodnar board, but there is already some stuff like solders, and this distance is already respected. Then I screw directly on the wood. You can see on this plan the different size of the pieces of wood. You have a 70 by 500 millimeters on the front, you have a 92 by 500 on the back, you have a 77 by 480 on the bottom, and you have on two sides 77 by 90. You must recut it to be in place. For the wires I plan to use, it's 30 centimeters Dupont wires. The length of these wires implicate that you must put the board in the middle of the box. So I cannot put the board on the side of the box, and I used an extension cable to place the board on the center of the box. And in my case, this place in the box was the better place because at this place the buttons are the smallest, and I wanted to avoid any short circuits. This is the LeoBodnar board. This is the BBI 64, which 64 pair of pins. Each pair of pins acts like a switch. The LeoBodnar board is recognized by Windows like a joystick, and each pair of pins act like a press button. So with this card we can bind up to 64 buttons. This is a three-legged switch with integrated LEDs. It's supplied by 12 volts, and you can choose any colors. You can plug it always illuminated or illuminated and extinguished. I've took this button, I've took the squared shaped and the latching model. This is the 1NO, 1NC. I could have taken the 2NO, 2NC button, which have two parallel circuits, which avoid me to use some relay, but this button was too big. I wanted the smallest. I've taken these rotary encoders, which have 20 position by revolution, and with an integrated switch, you can push the button. There is a switch inside. I've took this knob, the 21mm knob, for the rotary encoders, which was sold by the same seller, and beware of the shape of the shaft for compatibility. This is the on-off-on switch. I've took the two ways switch, which have two parallel circuits. So I will have a circuit for the LeoBodnar boards, and the second one is for wiring with LEDs and resistors. So the two ways model is this one, which exists with or without screw. This is the momentary rotating button. Be careful to take the momentary model in 3 positions and 12 volts, and then you can choose the color. This is the parking brake button, which is already in 12 volts because it's for the cars, and you can choose the model, and you can choose the color in red, for example, and be careful to choose the latching model. This is the lever switch for the gear button, which is an on-on switch. You must pull up the switch for changing the position, exactly like the real cockpit for the landing gear or Starling engine in the A320. This is a two-way switch for wiring some green and red lights for up and down gear. This is a 1 kilo ohm potentiometers to adjust the brightness of the external panel light. This is an assortment of resistors for any wiring. Then you have any resistor you may need in your circuit. This is a bicolor 5mm LEDs red and green, with the common cathode. An assortment of 3mm colored LEDs. I need only the whites. 5mm fog white LEDs. A 12mm self-locking with integrated LEDs power button. Some mini relays, they are very small, 1.5 centimeters by 1 centimeters. You need one relay by on-off switch with integrated light, and for any push button with integrated lights. You don't need it for rotary encoders, rotary button, etc. Some wire, I took the 22 AWG. Some wires with plugs and insulatings. It's sold by the push button sellers. I used that on the rotating button. Some Dupont cable with 30 centimeters wire. I use that to plug every button on the LeoBodnar board. A plug for the power supply I already have, which is 5.5mm by 2.5. If you don't know which plug to use, you can measure it on your power supply with a caliper, or if you buy a new one on the technical specification. A fuse box for 12 volts car fuses. So I'm using a 1 ampere fuse to protect the circuit and the power supply. This is the extension USB-B to place the LeoBodnar board in the center of the box, and the USB cable with a classic USB plug and a USB-B plug to plug in the box on the computer. So this is some picture of my box I have built with some plywood. I've cut it with a jigsaw. I used some nails and some wood glue to assemble it. And at the beginning, I've planned to use this kind of panel. I don't know how do you call that in English. We say in French that is some medium, and it's very fragile. When you drill it with even a very sharpened drill burr, it completely explodes. So I have to order a plexiglass plate, which give me a very clean result. So at the beginning I place my plastic plate like that with a press and some wood pieces below, and to have not to drill my bench. And it's a very bad idea, because your driller can quickly become a hammer, and I have broken my plate. I have to repair it with some glue, and it's a little too bad. Then I've placed a polystyrene plate below, and it's a lot better. To make the 12mm holes, I've used these pieces, which is a priming burr, because if you attack directly the plate with a 12mm burr, it's not very precise, which this object you will do a very nice work. So I've used that to make the 16mm holes for the square button and the 20 for the rotary button. So this is the plastic plate with the holes done, and we see the rift on the left. Beware of your drilling. I used some resin to repair it. So I've spoiled a hole in the middle of the plate with the milling cutter, so beware also with it. So I've made a squared and a round hole for the power supply and the USB cable for the extent of the USB cable. It was a bit difficult for the power supply because I have to dig a little in the wood to pass the nut of the screw of this plug. So I've painted the box with matte black wood paint, and this is the plexiglass plate with all the buttons mounted. I put the plexiglass plate on the box to verify if a piece impeded the mount, and there was one piece, the brightness potentiometer. So I have to sand down a little the wood to make it in place. So this is my customized button. The button from AliExpress have a plastic stopper which can be removed. So be careful with the disassembly because there is a teeny plastic pieces which are very fragile. I've made my logo with paint and I put it in a Word document to print it on the right scale, and I printed it on translucent paper. The first thing that I did was to glue a relay beside each button needs a relay, like on-off switch, push button and parking brake. I hadn't talked so much about the relays. The relays are a little piece of electronics which two independent circuits. The goal of a relay is to isolate two circuits. One thing you must know about LeoBodnar boards is that you can only plug a button on pins, and the switches and buttons with integrated LEDs are supplied by 12 volts, and if the voltage goes to the board, you may fry it. That's why I use a relay to isolate the circuit of the 12 volts on the LeoBodnar board. So this is a wiring diagram of the only two ways of wiring this switch. So as you can see, you can have only two options. On the left, you have the first option we want. The switch is illuminated in the on position and extinguishes in off position, but there is a voltage between the pins of the switch and this pins goes to the LeoBodnar board. So that is not good for the LeoBodnar board, but it's good visually. On the right, it's good for the LeoBodnar board because there is no voltage on the pins, but the light is always illuminated. To make it work, we're going to use the left option, and we will use a relay to isolate the 12 volt on the LeoBodnar board. To see exactly what's going on with the relay, I did a little diagram. So you can see on the left the first circuit with a coil, and on the right the second circuit with a switch, and the LeoBodnar board is plugged on the switch. When an electric current is going through the coil, there will be an electromagnetical field. This will push a little magnet placed on the circuit of the second switch. So if I activate it with the battery, we hear clearly the contact. So the pins of the coil and the pins of the switch are indicated on the data sheets. So the new wiring diagram of the on-off switch with the relay looks like that. Now we have our switch with LED illuminated in on position and extinguished in off position, and we have always 0 volts on the green wire which goes to the LeoBodnar board, which is totally safe. So this is the first solders. I've put a red and black wire on the plus 12 volts and the ground, which are soldered on the side of the switch. I've also soldered the wire to the coil of the relay. I now use a battery to control if all the switches illuminate correctly, which is the case. The only default I've found on the switch that are a bit difficult to manipulate. I've soldered the DuPont cable, like in the diagram. This cable will be plugged into the LeoBodnar board. Concerning the push button with integrated LEDs, this is the diagram. I don't show the wiring diagram for the relay because it's the same as for the switch on-off. So to see it more clearly, I made some little group, then I can test it independently, and at the end I will solder all the groups together. For the parking brake, the wiring diagram is the same as the push buttons. So we see here some details for the push buttons wiring. The green wire of the diagram is here, connected to the C and the plus of the push button, plus 12 volts in the center with the red wire, the ground with the black-red wire on the minus, black-red goes in black to the relay, and the DuPont connector in the internal switch of the relay.
Voilà. Vous branchez le fil rouge sur le bouton rouge, le fil vert sur le bouton vert, vous appuyez et plaf. Et rappelez-vous, le fil vert sur le bouton vert, le fil rouge sur le bouton rouge.
Bon, alors le fil vert sur le bouton vert, le fil rouge sur le bouton rouge. Le fil vert sur le bouton vert, le fil rouge sur le bouton. Bon, bah, je vais essayer le vert sur le blanc. C'est pas ça. Je vais essayer le contraire. C'était ça. On nous a bombardés par en dessous, chef. Une mine. Bon, alors se rappeler, le fil rouge sur le bouton blanc, le fil vert sur le bouton blanc. Le fil rouge sur le bouton blanc.
So after this little relaxation break, I'm gonna check all the push buttons. I've plugged a battery on the plus 12 volts and ground of the central group. So at this time I always have several groups with the red and black wire here. Another here. I will connect all the groups at the end of the build. So this is the wiring diagram for the rotary knob. I talked about this knob before. These buttons are momentary reset. That means that when you push it on the right or on the left, they goes automatically in the center when you release the button. This button has integrated LED to report its presence. It's fed by 12 volts and the wiring diagram is extremely simple. You put the 12 volts on the plus, the ground on the minus. Then you connect two DuPont cable on the L, O and C and you have a true button for the increment and decrement. To connect it, I used this stuff, and I soldered the DuPont cable directly on it, and I isolate with a heat shrinkable sleeve. If you have some kids, you can use them for put on the heat shrinkable sleeves, because with their little hands they will do a very, very good job. Not as you with your big paws. Here we have the connector on the knobs. So here we have the different groups that I had tested independently. I tested this group with the battery. I hadn't put the power supply at this time. So here I have connected the waiting wire of the different groups, the plus 12 volts on the plus 12 volts of the precedent group, the ground on the ground of the precedent group. You can connect on any plus 12 or ground, no matter which one. You just don't have to reverse the two. So here we have the wiring diagram for the rotary encoder. Rotary encoders are an electronic part you can have in many electronic stuff, like in microwave for the heat time. Rotary encoders are not like potentiometers. When you turn it, you feel like some detents. LeoBodnar boards see it like a press button, and when you turn it on a way, it's like you press several times in a row. And when you turn it on the other way, it's like you press another button. That's why you can bind two functions with this, like reduce and increment heading or speed, etc. For the wiring, you solder both of the wire of the first DuPont cable and only the red one for the second DuPont cable. At the first time I did a mistake. I soldered the two black wires on the center pin, and that's a mistake that don't work. On this video you can see I soldered both black wires and that won't work. I cut one of the two, and it works perfectly right now. The two bottom green wires are for the integrated push button, so we have 3 DuPont cables for one encoder. So right now I'm gonna show you the wiring diagram for the landing gear. The goal is to have a green light when the landing gear is extended and red when it's retracted. So I used some bicolor LEDs, red and green, with 3 legs and common cathode. But in fact this is 2 LEDs in one component. In the technical datasheet you can see both colors won't use the same voltage and so the same resistors. Here we have the technical datasheet, and you can see here that the red color will use 2 volts to 2.2 volts and the green 3 volts to 3.2 volts and 20 milliamperes current for each color. So I went to the DigiKey website and I calculate the resistor to use. So I put the 12 volts of the power supply, 3.1 is the LED voltage, and 20 is the current used by the LED, and it calculates automatically the minimal resistor to use. DigiKey calculates a 450 resistor for the green color. I did the same thing for the red color. So I used the common resistor of 300 ohms and the 200 ohms on the red side and the 150 on the green side to respect the resistor value calculated by DigiKey. On the LED, the cathode is located by a flat side, a short leg, and a line on the symbol. LEDs illuminate only in one way. You must connect the cathode on the minus pole of the power supply. So to start, I've put the 3 LEDs on the holes in the same way, and I've cut one anode, and with the battery and a 500 ohms resistor I've tested which color is the cut anode. So once identified, I soldered a 200 ohms resistor on the red side. And I've soldered a 150 ohm resistor on the green side. I've put some heat shrinkable sleeve. I soldered each red anode together, same for the green, and I soldered a 300 ohms resistor on the cathode. I've put some heat shrinkable sleeve and I soldered the three cathodes together and then I heated the shrinkable sleeve. On the power button I soldered the wires that will power the whole circuit. I soldered the black wire of the ground on the three cathodes of the three LED of the landing gear. Then it goes to the first ground on the parking brake button, and it goes on the other ground on the other components. The red wire of the power supply is soldered on the left leg of the power button. The wire here, which is on the right leg of the power button, comes from a plus 12 volts taken to the circuit, and here I have a loop between this leg and the plus pin of the integrated LED. I have some bad contacts, the pins are very close. I will put some shrinkable sleeve. This pin is the minus of the integrated LED. I will connect it to a ground no matter which one, for example here on the parking brake. So I take a plus 12 volts on the circuit and I connect it to the middle leg of one way of the landing gear button. Then I will connect one leg of the same way on one color and the other on the second color. So the wires has been soldered. On the second way we connect one dupont cable on the center leg and the one external leg. Once it was finished, I felt that the green color was too blinding, and then I add a 3.3 resistor on the green color. So now we're going to start to create the circuit to illuminate the external panel light. So we have two couple of LEDs with a 300 ohm resistor. Each couple are in parallel. We have a 1 kilo ohm potentiometer to adjust the brightness. On the potentiometer we will solder a plus 12 volt on the E1 leg. We will solder together the C and the E2 leg. Then we have the two series of two LED and one resistor in parallel, and then we go to the ground. We remember that the LED cathode is the short LED, and on diagram it's a line. I mounted the four LEDs with the cathode on the left. So we take the LEDs 2 by 2 and we solder a cathode of a LED with the neighbor LED anode. After a series of two LEDs we have a 300 ohm resistor. So I soldered a resistor on the cathode on the left. After that the two resistors are soldered together. I've put some sleeve to insulate. On the other side of the two series of LEDs, the two anodes are connected. So I soldered a wire to connecting the two anodes. Then I took a plus 12 volt on the circuit and I soldered it on the E1 leg of the potentiometer. Then I soldered the two anodes already connected to the E2 leg and the center leg of the potentiometer. And finally we start from the two resistors and we go to a ground. So now we're gonna take a look for a wiring of a on-off-on switch. I've taken this switch for the nose light of the A320. The three positions of the nose light is taxi, off and takeoff. The nose light function is not implemented for now, so it's a waiting button. In this video you will see further picture where there is not this button. I was waiting this button and I mounted it at the end. I'm gonna show you now its installation to respect the chronology. On the plastic plate I had drilled two 3mm holes. I've put two white LEDs with the cathode on the top. I've put some insulating tape because there is metal part on the switch. Here we have the switch on the hole. I went to the DigiKey website and calculated a resistor for these LEDs. The website calculated me a 450 ohms resistor, which is the minimal value, so I've put a 680 ohms resistor to reduce the brightness of the LEDs. So I soldered a 680 ohms resistor on the center leg of a way. The wiring diagram is quite the same as for the one for the landing gear, except the two LEDs are the same, so we need one resistor. I've taken a plus 12 volts on the neighbor button that I connect to this resistor. I've soldered two black wires on the other legs of the buttons, and I've bent up the two anodes. I've put some heat shrinkable sleeves and I've soldered the two black wires on the two anodes. At this time I did a mistake. I've inverted the two black wires and the button was up, the bottom LED was illuminated, and conversely. In further picture I've put the wires in the right way. The LED cathodes must be connected to the minus pole, so I've taken ground and I've soldered the two cathodes. On the second way of the switch I soldered the two DuPont cable. I've took two pairs of wires, the two black wires in the middle and the red on the outside. We can look here the two black wires in the right position. Here we have a look on the other side. On the plus of the power supply plug I mounted a fuse box with the 1 ampere fuse. I mounted the wires seen previously, the plus on the fuse box and the minus on the minus of the power plug. The box will be powered by a plus 12 volts 1.5 ampere. So I did a test to see if all the buttons illuminate correctly. I did a little mountings with two DuPont pins and cables to test the buttons one by one. We must verify that the button is contacting correctly and there is no voltage on the DuPont cable. So we have the multimeter in volt position, we see there is no voltage, and I put it on ohm position to see if it contacts correctly. I had tested all the buttons with integrated LEDs because they are supplied by 12 volts. For rotary encoders, ohm position is sufficient. Then I made the LED heater with a piece of wood. I used for that a milling cutter, thing to cut the piece at the end. I used the cutting rod to make the lever of the landing gear, thing to make the hole before to cut the piece of wood. To protect the piece of wood, I used a vitrifier. I drilled the fixing hole for the plastic plate and I put the LeoBodnar board in the center of the box. I've put a multimeter in the ampere position on the fuse box to see when all the buttons are illuminated how much current it used. As you can see, it used 550 milliamperes, so my 1 ampere fuse and my 1.5 power supply are well dimensioned. Now it's time to put the labels and the knob of the rotary encoders. I used the glue gun on the solderings of the DuPont cable to avoid them to break. All the DuPont cables are connected to the LeoBodnar boards with the black wires on the outside. All that left is to bind the buttons in the simulator. One thing, the on-off button and the switch on-off are a bit particular. You must use the software to convert the on-off in toggle. The first thing to do is to use the LeoBodnar utility to assign buttons on rotary encoders. You must use consecutive pairs of buttons for encoders. For example, B1, B2, B3, B4. You can't use B2, B3, for example. If you use several encoders with integrated push button, pay attention to not place them at the following. For example, you'll have the first encoder in B1, B2, and the push button in B3, and then the second on B4, B5, and it will not work. You can place the DuPont cable of the encoders at the following, and the integrated push buttons on another place. All encoders are different. Those I had by are 4 pulse by detent. It means on one detent the button activates 4 times. I set on the software 1-4. For the encoder pulse width, the parameter in the bottom, I used my simulator in window width mode and I changed the value and keep the best one. Then I used a software called VJoy. VJoy is a software to create virtual joysticks. I created a joystick with 64 buttons, exactly like the LeoBodnar board. Then we have to download and install the software called Joystick Gremlin. With this software and VJoy, we can translate the on-off action on the LeoBodnar board in toggle or key press, exactly like when you press a key on the keyboard. We must use that with on-off switch. If not, your simulator will believe that you are continually press a key when your switch is in on position and you are doing nothing when it goes to off position. Then, for example, you down your landing gear and the landing gear is extended. Then you up the button and nothing happened. And then you have to down a second time to retract the landing gear, and it makes incoherence between your plane and your button box. In Joystick Gremlin, we're going to see the 64 buttons of the LeoBodnar board, but also the 64 buttons created by the virtual joystick. When we will push a button on a LeoBodnar board, an on-off switch or an on-off button, the LeoBodnar board will see on or off. With the macro, we will convert the on-off action on the LeoBodnar board on the top in toggle or key press on the bottom on the virtual device. Here we have a demo. On the top we have an on-off switch on the LeoBodnar board. which been converted in toggle on the bottom. We have to do a macro exactly like the following screenshots, and then we will bind the VJoy buttons in Flight Simulator. This is the end of this video. I hope you enjoyed it and my English wasn't too bad. I hope that I will have thus reached more people than the French-speaking community and that you will be able to build your own button box. This video gives the outlines and a button box is completely customizable.
Request accepted.
Airbus Alpha Sierra, X-ray tree, 20 cleared for takeoff runway 22.